All right, so this isn't going to be the best quality recording a laptop screen from a cell phone, but I hope it's at least tolerable. So this is the latest project I've been working on. It's a block driver, and right now I'm calling it the BD100, which I know is kind of cheesy, but that's what I'm going with for now. It's going to be for an HO scale DC layout. So what I'm going to be doing is taking a PWM signal from, say, a microcontroller and using a op amp to convert that to an analog voltage. So it uses a DAC with an H bridge to send that voltage and that current through these NPN transistors out to the rails. So it can do plus or minus 5 amps. And it uses an H bridge to send that amperage out to the rails. And it can do forward and reverse, of course. And you can change the direction using this input here. So if you bring it high, it'll change the direction to reverse. If you bring it back low, it'll go back to forward. So this is a pretty common building block for electronics, this H bridge driver. And these circuits down here are for LED indication, so there's going to be several LEDs on the circuit board itself, and then there's going to be some extra circuits here so that you can have external LEDs, say, on your control panel, which I'm definitely going to have because control panels are awesome. So that's basically the engine of the block driver right there, the DAC with the H bridge. Now up here we have, of course, power monitoring. We got to have short circuit detection on the board. So that's what this does. And not only does it do short circuit detection, but it does over voltage and under voltage detection. So that's what this chip does here. It's basically a gate driver. So it drives the gate of this N-channel MOSFET. So if it detects any funny business going on the rails, it'll turn off this MOSFET and thus disallow current to flow through out to the rails. So that's bidirectional, so it can work when the locomotive's going forward and when it's going in reverse. So that's all that means. Now there's also block detection here. Of course, we got to have block detection on a block driver. So that's what this chip is doing. Now, the trip current you can set anywhere between 1.875 milliamps and 4.8 amps, and that's bidirectional. So if you want this thing to trip, you can have it do that and control these relays here. There's a couple of relays. And the reason why there's two is just in case you want one to be normally open and one to be normally closed. They're going to be AC and DC, standard single pole, single throw relays that can do at least 5 amps. So that's what that is. And then you can also have signal sent out to a microcontroller or an LED on your control panel or whatever using this output here. And there's another LED. Of course, I love LEDs. So that is what's going on there. Then we also have the voltmeter. Can't forget about the voltmeter. So right on the circuit board, there's going to be a 4-digit 7-segment LCD or LED display, and it can display up to 19.99 volts using this fantastic chip right here, the ICL 7107, which, by the way, is basically a DAC. It's just used instead of driving a locomotive, it's driving a display that can display voltage. So that's what that's doing right there. And yeah, so that displays the voltage that you're bringing in to your rails. So that's, did I miss anything here? That's pretty much all that's happening. So this is obviously in the design phase. Oh, here, reverse polarity. You gotta have reverse polarity protection. So I don't know why more designers don't put this in their designs, but it's very easy to implement. You gotta have reverse polarity in case an idiot like me would hook it up the wrong way around and blow up the board. So gotta have that. It's a pretty standard circuit that you can find on the internet. So this one's for the main voltage that goes out to the rails, and this one is for the 5-volt supply. So that's what's going on. Got lots of inputs and outputs here. And yeah, the BD100. So that's what this is all about. And I'm very excited for this. Right now I'm working on picking out the components. It's going to be a lot of surface mount jobbies. So probably going to have JLC PCB SMT service assemble the surface mount components on the board, because I like to cheat like that and not do it myself, because I would totally screw it up. So I think I'll have them do the surface mount components if I can, and then I will do all the through-hole components, such as the 7-segment displays and other things, the relays. So that's the plan. Then after that, after I've got everything named right, all the footprints right, all the components I want, I will start designing the actual printed circuit board. So that's the plan. Really, really excited about this right now. It's one of many projects I've got going on. So yeah, so this is going to be for a DC layout, and it's much more than just a transformer connected to track. But I'm using that principle right here for the DAC with the H-bridge driver. So that's what this is, basically emulating your conventional transformer that you connect to a track, except you can control it with a microcontroller using PWM. Yay. So that's what that's about. And I will keep you updated on the progress of this and how it's all going. And thank you for watching the whole video if you made it through. And have a great week. I'll see you next time. Bye-bye.